Alright, now let's look at the first example on the screen. The question is asking for the extension produced on a spring that constant is 5 Newton per meter when you use a mass of 50 grams. So if we are bringing out our parameters, the mass used is 50 grams, spring constant is 5 Newton per meter, and we are asked for extension. First rule of the game is to ensure that all units are in tandem. If you remember, I said so, right? So currently we have the constant in Newton per meter. So what that means is that we need to be using forces in meters and distances, forces in Newton and distances in meters. So 50 grams, we'll convert it into force. So this implies that force will be, I said, for grams to Newton, just divide by 100. So we are working with 0.5 Newton. So since the formula say F is equal to KE, change this force into 0.5. This will be equal to the 5 times E. Dividing both sides by 5, the extension is 0.1 meters. Very easy, very easy. Now let's look at the second example. Now for this question, the force is 40 Newton. The spring constant is 8 grams per centimeter, and we're asked to find the extension. Remember what I said? So this is gram per cm and we're having it in Newton, so that doesn't make sense. It's either we're going to change Newton into grams or we change this unit into Newton per meter. And I think it's easier to convert the K right now, because what I said was that gram per cm is exactly the same thing as Newton per meter. So this automatically is 8 Newton per meter. So what that means is that our E will be force over constant. So what does that give us? 40 divided by 8. So our extension will be 5 meters. Easy one. But for some other people who would want to go the long way, we are not going to like what this gives us, but let me give you the second way. Or we could have worked on the force, convert it into grams, which of course is going to be stressful. First of all, we know that to get mass out of it, we will divide it by 10 because of gravity, right? So that means this is 4 kg. And if you convert 4 kg into grams, it's just moving the kilo and multiplying by 1000. So the mass was actually 1000 grams. Okay, we can work with it when it is like that. So changing that formula that says F equal to KE, we are going to change it into M equals KE, and it will work because the mass is 1000 equals the constant, which is 8. No, sorry, mass was 4. Sorry, it was 4 kg. That's 4000 I meant to say. So this is going to be 4000 equal to 8 times extension. So extension becomes 4000 divided by 8. That gives us 500. But since this was gram per cm, this is 500 centimeters. Extension still comes out as 5 meters. So it doesn't matter where you do your conversion, the answer is always going to be the same. So I would advise you to go for whichever one you are very familiar with. If you're familiar with converting the K, use it, convert it to match, and then solve your problem. So now let's look into the next example. Industrial weighing machine was to weigh a force of 60 Newton. So the force provided is 60 Newton, and we were given the original length of the spring as 50 meters. So the L naught is 50 meters. The spring constant is 500 gram per meter, and we're asked to find what the final length would be. Of course, this is still just coming from F equal to KE. We just have to make sure that the units are matching, and it's either I'm changing Newton into grams or I'm changing gram per meter into Newton per meter. I would like to go here because it's much easier. I just need to change gram into Newton and everything is good to go. So changing gram per meter into Newton per meter, I told you what to do. We just divide by 100. So this is going to give us 5 Newton per meter. Now we can go. Since F is equal to KE, the force is 60, the K is 5 times the extension. If we divide both sides, extension will be 12 meters. But they didn't ask for the extension, they asked us for the length it will stretch to. So therefore, to find the length, we will use the original length to add to our extension that we have solved. So this becomes 50 plus 12. That gives us 62 meters. Let's look into the next question. Okay, this particular question is quite exciting. We were given the spring constant as 2 grams per cm, and the original length of the spring is 15 centimeters, and they're asking us to find what mass that will give it an extension of 10% of the original length. So all you just have to do, work out 10% of 15. So 10 over 100 of 15, that should be 1.5. So we're working with an extension of 1.5. Now you notice what's going on here. The K is in gram per cm. The extension I'll be using is in cm. So I don't even need to convert anybody. I can work with it like this. So I'm going to use a formula that says M equals KE to work, because everything is in grams and it's in centimeters. So what am I putting here? The unknown mass will become equal to the constant, which is 2 gram per cm multiplying 1.5 cm. Of course, if cm can take out the cm, and 2 times 1.5 gives us 3.0 grams. Of course, that's the mass needed to stretch it by 10%. But if you were asked to find the weight, just still do this, and to get the force or the weight that will do that, you divide it by 100, as I always do, 0.03 Newton. All right, so this is enough example related to Hooke's law, the equation itself. Let's look at some examples now that we'll be handling, that will be tackling issues on those ratios we listed previously.